so let's take a look and see if I give you a crazy graph, because I can give you a crazy piecewise function here graphed out, how we can find what the limit is and if it exists or if it does not exist. So if we look at this graph, it's got a lot of things going on. I've got two vertical asymptotes right here. I have a jump discontinuity here. I have a removable discontinuity here, and I have a removable discontinuity here. I have an x-intercept here because this is not an asymptote. There'll be another x-intercept down here somewhere. I have an x-intercept here, and I don't really have an x-intercept here because that's a hole. That's the removable discontinuity. So I've got some questions here, and we're going to just kind of go through and talk about it. So let's look at this first one I have, f of -2. Well, this is just algebra 1. I give you a graph and I ask you where f of -2 is. What's the y value? I'm going to go to -2, and I have two options. I have a hole. Well, it doesn't exist there, but it does exist right here. My y value is a closed dot, so that's going to be 1. So f of -2 of this graph is 1. Now let's look at the one below it. The limit as x approaches -2 of f of x. I put this on purpose because I've seen students think, oh, wait, these are the same. They're not always the same. Sometimes they are, but they're not always the same. Because if you remember to find the limit, we have to be approaching the same number from the left and the right. So I'm not approaching anything from left and right up here, but down here, as I'm coming in from the left and the right, I'm actually approaching 1/2. So the limit as x approaches -2 of this function f of x is 1/2, because as I'm coming from the left and the right, it's approaching 1/2. All right, so let's look at the limit as x approaches -3 of f of x. All right, so as this is approaching -3 here, and it's approaching -3 here, not even approaching a number, this is unbounded. So right off the bat, this does not exist. Does not exist because it's approaching from the left and the right, and both of them are unbounded, so it does not exist. All right, well, let's look at the limit as x approaches 0 of f of x. So if I'm coming in this way, it is approaching 0. But if I'm coming in this way, it's approaching 1. So it's approaching a different number from the left and the right. So this limit also does not exist. Now keep in mind, in AP Calculus, they may also use the word non-existent. The limit is non-existent. In this case, it's because they approach different numbers. All right, so now let's look here. The limit as f of x approaches not -3, it's supposed to be 3. The limit as x approaches 3 of f of x. So I'm going to come over here to 3, and this is another one of those things where students will make a mistake because they're so used to seeing what's f of 3. Well, f of 3 is 1. That's not the limit, that's f of 3. The limit has to approach the same number from the left and the right. So as I'm coming in from the left and the right, the y value that I'm approaching is 0. So you just use the graph and you kind of use your different rules. It has to approach left or right. You have to keep in mind of unbounded oscillations, and if it's approaching a different number, because those are the 3 common instances where the limit does not exist, or it's going to approach a specific number, and that's what the limit's going to be. Doing it with the graph is pretty straightforward, fairly easy. It's a little harder when we take the graph away and you have to do it algebraically. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.